Problem is this?
It's problem 11.
On page
522.
522?
Yeah, so it's just sine theta equals negative 0.45.
0.45?
Yes.
Okay, so if that's the case, then we're going to, we have no idea what this is, but remember sine is defined here,
Mhm.
right? Between negative pi over 2 and pi over 2. Therefore, if this is a negative number, I want to find, I need to find an angle here.
Mhm.
So this angle. However, because I'm interested, because I have a negative number, so I will be okay with finding this angle, which will be negative.
Okay.
And then if you want, you can transform it into a positive angle if you want to. But let's keep the answer between negative pi over 2 and pi over 2. It doesn't have to be in radians, but it has to be between, if it's in degrees, between negative 90 and positive 90. Okay? Okay. So the only thing I can do is just go to the graphing calculator. I have no choice.
Um,
So I apply sine inverse to both sides, of course.
Okay.
Yes.
Oh, that's how you do that. Okay.
Yes, there is no other way. So second sine inverse applied to negative 0.45, close the parenthesis, and make sure that the mode is in whatever you wanted it to be in. So if you want degrees, then change it to degrees, and then press enter, and you will get roughly negative 27 degrees.
Okay. And then that's the answer.
That's it. Now, if you want it in radians, then you redo the problem and change the mode into radians, or just you know how to convert degrees into radians. So press enter, and you have negative 0.47.
And this is going to be pi plus k would be.
If you want to give the answer in the positive angle. But I would keep it as negative 0.47 approximately radians,
Okay.
or negative 26.7 degrees. Did they give the answer in a positive angle? They shouldn't.
No, they didn't.
They should not.
They just put all that k plus pi k.
Yes. Yes, plus 2 pi k. Yes. If the question is, I didn't open the book, so if the question is asking us for all possible answers,
It
then,
just solve the given equation.
okay,
Yeah.
then we are not restricted to one complete rotation. So I will write, so I'm applying sine inverse to both sides. And then I have theta equals negative 26.7 degrees plus 360 degrees K. Or I would write theta equals negative 0.47 radians plus 2 pi k. And you have to explain what k is. So you have to put this in writing. Good. Next question.
Can I do
Yes.
a 7.3?
Yes.
Let's see. So page 550. Use numbers. Let's see. We have like 32.
Okay. Do I need the book? Oh, okay. I'm disappointed about that file. Still thinking about it. So page, you said 515, problem 32.
Yeah, sorry, we did 32.
That's okay. Anything else?
Yeah, let's do a 34.
Okay. So page 515, problem 34. Okay. So in 34, we have the square root of 1 minus cosine 30 degrees divided by 2. So let me remind you two very important formulas. Sine of a half angle equals plus or minus the square root of 1 minus cosine of the angle over 2. And cosine of the half angle is plus or minus the square root, the same thing but plus. Very important identities. So obviously if I see something like this, I have to think in terms of sine.
Sine is the minus.
Yes. So if this is 30 degrees, this must be 30 over 2.
Right.
So it's sine equals 15 degrees?
The
Sine 15 degrees is the square root of 1 minus cosine 30 over 2. Correct. So these have to be remembered. We developed these together. I did not ask you all of a sudden, hey, memorize these. If you remember, we started with cosine twice alpha.
Mhm.
And that's how we got to this.
One of these, that's for-
Oh, there is one more. What will you say about the square root of 1 minus cosine 8 theta?
Sine 4 theta?
Yes.
So that would be you would have to solve, but you would have to find sine of 17 degrees.
No, we are not asked to do that. Let me see. Let me see. Simplify the expression.
Okay.
It doesn't say evaluate or find.
One I had questions about,
Yes,
maybe we don't have class.
it's okay.
It's on page 506.
506.
Yeah, the 35 is cotangent of x minus y.
Cotangent.
X minus y.
This.
Yes, ma'am.
Okay, very good. So remember, this is cosine x minus y over sine x minus y. So far, so good?
Well, and they put equals cotangent x, cotangent y.
Oh, so it's an identity.
Yeah, it's an idea. Sorry, I didn't.
Oh, so you're just giving me half of it.
Yeah.
I got it.
But, yeah.
Okay, so in any event, I'm starting with the left-hand side then.
Okay, yeah.
That's it.
Where I was starting.
Okay, so then the top will be cosine x, cosine y plus sine x, sine y.
Oh, wait, you would still do that right there? You just keep going? Okay.
Okay, never mind. Let me look at the problem. Because I only get partial truth here. Okay, 506. It's 35. So this is an identity. Okay. Good. Well, I started now. I can't go back. I'm at the point of no return. And this is sine x cosine y minus sine y cosine x.
So you have cosine x, cosine y, plus sine x, sine y, because cotangent.
Because that's the formula for cosine.
Yeah, it's cosine.
No, that's the formula for cosine x minus y. Cosine x cosine y plus sine x sine y. And this is the formula for sine x minus y. Sine x cosine y minus sine y cosine x. Okay, and now I'm going to force, because I was forced to go on this route now. So I will factor out sine x sine y from the top, and the denominator on the right hand side is cotangent, yes, x cotangent y. And here I will factor out sine y cosine x. Let me see. I have to get a cotangent y. So I have to have cosine over sine. No, I have to move, I have the same thing. Cosine, sine x, sine y. Okay, let me write this again. Only because I started from the left-hand side, now I have no choice. Sine x, sine y, sine x, sine y. Both of them are the same. Okay, let's see now carefully what we have left at the top.
Cosine y.
Over sine x, sine y is what? Let's write it. Let's see it first. Cosine x, cosine y over sine x, sine y, and then plus
Sine x, sine y. So how do we get that over that?
so when I distribute it back, this will be simplified and I get that, plus this times this has to be this.
Oh, 1.
Exactly. Is that clear? When I distribute this back, I get that. And when I distribute it here, I get this.
Oh, okay.
Let's write it again. Let's not calculate anything without seeing it. Perfect. Good. So what do you think I'm going to do with the top, with those two pieces in front? Good. So now let's look at the top. Yes, you can peek to the right-hand side of the equation, of the identity. So what is that? Cosine x, cosine y over sine x, sine y. And you can look where we are heading to. So what is cosine x, cosine y over sine x, sine y? What is this? What is, yes, very good. So the top is done. What do I have to do to the denominator? What is cosine y over sine y? Minus? I took a different route, I'm sure, than the one that we did initially because I was not given the whole truth from the beginning. So once I started, I had no choice.
So can you, like, so the way that, like, I was trying to follow it from the book.
Yes.
Not that way, but,
There is a solution step by step in the back of the book.
Yeah, on these ones.
yeah, there it is.
Awesome.
So they put 1 over tangent x minus y.
Yes, because cotangent
Yeah, it's 1 over
is 1 over tangent.
Yeah. So I was trying to work it that way, but I got lost.
Yes, let's do it that way.
Okay.
So what does it say again?
Okay, so it says.
They start from the left-hand side.
And they go 1 over.
So this is cotangent x minus y, okay, which is 1 over tangent x minus y, which is 1 over, and I know the formula for this, is tangent x minus tangent y over 1 plus tangent x tangent y. I flip this, so it's 1 plus tangent x tangent y over tangent x minus tangent y. And now we have several ways. One would be to change back into sine and cosine. The other one would be to factor, possibly something to simplify. So let's go the route. What did they do? Did they change it back into x sine x, sine y?
They made it 1 plus 1 over cotangent x and 1 over cotangent y. That's what they put next. After they flipped it, they put 1 plus 1 over cotangent x.
Yes, we can do that. So change now tangent back into cotangent. That's fine too.
I mean,
Yep, there are different ways.
Yeah, that is-
So then 1 plus 1 over cotangent x cotangent y, that's perfect. And 1 over cotangent x minus 1 over cotangent y. Now we find the LCD at the top. And we find the LCD in the denominator. I multiply this by cotangent x cotangent y plus 1. And then I multiply them, this one by cotangent y minus cotangent x.
And you split multiply.
Exactly. Those two will go away. So I get exactly what I want to. Cotangent x cotangent y plus 1 over cotangent y minus cotangent x. And this is the right hand side. There are different ways. Good, very good question. Anything else you tried? Anything else you worked on? Let's look at the chapter test. Is on page 532, and also at the review exercises for chapter 7 from 1 through 72 on 530 and 531. But I'd like to answer your questions first if you have anything else.
Probably not. We do another 7.3.
Yes, of course. Anything?
Yeah, unless you have something.
No, I would like to answer your questions first so we can start the review.
So, number 44 on 550.
44 on 550. I don't understand how that file was not created because I always open the file is there, and then I rename the file. So I don't understand why the file is not there. Because I always scan them and I send them to myself. I open them, they open. I see because I have several classes, right? And I need to open the file to see how to name it and which class it belongs to. So I don't understand why the file is not there.
It's okay. My computer at work makes me.
Okay, well, what was I doing? Okay, so tangent twice, is that the one? Tangent twice cosine inverse x?
Yeah.
Perfect. Okay, so I'm asked to, the question is asking, write the given expression as an algebraic, blah, blah, blah. Okay. So I look at this problem, and where would be my starting point? Where do I look first?
The inside.
Yes, excellent. Which portion or piece of the inside I look at?
Cosine inverse.
Correct. And I ask myself, is this an angle or is this a number?
It's a number. It's an angle.
Of course, because I apply cosine inverse to a number to get the angle, because I apply cosine to an angle to get the number.
Are we talking about x? My bad.
Oh, I'm sorry, my mistake. Okay, so the question is cosine inverse x an angle or a number?
The x is a number.
X is a number, correct. So the answer is that clear? So one more time, we apply cosine to angles, but we apply cosine inverse to numbers. Clear?
Yeah.
Okay, what do I do now?
And cosine.
Right, I apply cosine to both sides, so then I have cosine alpha equals,
X.
correct. So now let's look again for a moment at what am I asked to find? Well, I'm asked to find tangent of what?
Cosine of x. 2 cosine of x.
Careful.
2 alpha.
Exactly. I'm really asked to find tangent twice alpha. I know the formula is twice tangent alpha over 1 minus tangent squared alpha. Once I establish that, the rest should not be very complicated. So what do I need in order to determine this? I need to determine tangent alpha. So I know this, so I form a right triangle with an acute angle alpha, whose cosine is x over 1. So which one is x?
Adjacent.
Which one is 1?
Fine.
Exactly. Therefore, the other leg is the square root of,
X squared plus 1.
careful, from the hypotenuse squared. Exactly. So now all I have to do is find tangent here for alpha. How much is tangent alpha? Oh, this is a nice example. Maybe I should put it on the test.
Have you not made the test yet? If we could avoid double and half angle.
So, how much is tangent alpha?
1 minus x.
That's 1.
Tangent.
Is
Yes?
opposite over adjacent.
Good.
Square root of 1
Yes.
minus x squared.
So now I can go back in here and put it in. Ready? Twice that. One minus, oops, I said minus, but I put plus. So 1 minus tangent squared. So please square that for me.
Square what? That thing?
Tangent, right. So 1 minus this squared.
So 1 minus x squared over x squared.
Exactly. So this is still preliminary, right? This is not final because I have not simplified this complex rational expression. Okay? So I first have to do something here.
LCD.
Yes.
So x squared. Cosine of x squared.
I have to change 1 into x squared over x squared. I have to distribute negative 1 to the top. Do we agree with me so far? Yes? Everyone? Okay, then the next step, 2 the square root of 1 minus x squared over x times x squared over 2x squared minus 1. And the only thing that goes away is,
X squared and x.
yes, just one of those.
Yep.
And I rearrange, I do not leave anything or write anything after the square root. So then I have 2x the square root of 1 minus x squared over 2x squared minus 1. A lot of work on this problem. Anything else before we look at the end of chapter 7 and the chapter test?
Yeah, I had a question about one.
Okay?
Was reducing the powers. Yeah.
What?
I can't remember what section they were in.
Which, chapter 7?
Yeah, chapter 7, like reducing the power.
Oh, yes.
Yeah, that's a doozy.
Yes, it's still on page 514,
Oh, yeah.
at the bottom of page 514.
Oh, yeah. So,
Which one would you like to work on?
it doesn't matter. They're all complicated.
Yes, they are.
13?
Okay, let's look at 13. Cosine squared sine to the fourth. Cosine squared sine to the fourth. Good. Let me remind you the formulas, or you will tell me and I'll write them. So we know this. Sine squared alpha over 2 or x over 2 is, I put squared, so I don't need the square root. That's why I put the square there. Good. So sine squared x over 2 equals 1 minus cosine x over 2. We used this formula half an hour ago. If this is x over 2. But I can rewrite this as sine squared x equals, and I want you to tell me what to write. So I'm replacing now x over 2 by x. So it's the same formula, but of what? Exactly. Because if this is x, remember this is x over 2, then this is, if this is 2x, that has to be 2x over 2. So the same thing with cosine squared. Can anyone now give us the cosine squared formula?
1 plus cosine of 2x.
Very good. So these are the two formulas we have to use for this. I pointed out this formula because we used it a few minutes ago, and I want you to make the connection. Here it is. The only difference was that here I took both a square root from both sides. That's why I had plus or minus and not squared. Same formulas are here. This is the same with this, but it's squared. So this is squared, and I don't have the square root here. And from this formula, I can write anything else. I need these two with x. Why? Because that's what I have. I don't have x over 2. I don't have x. I have 2x, right? I only have x. So I have to use these two formulas. So I will be replacing this by this, and this by this squared. Excellent. Yes. This is not a trivial problem. So let's do it slowly, because there is a lot of multiplication involved. So cosine squared, 1 plus cosine twice x over 2 times, I put the square so I don't forget, 1 minus cosine twice x over 2. Remember, you cannot separate 2 from x from cosine. Okay. Now, I leave this alone, but I have to square this. And this is the formula that or the special product that we agreed on from the very beginning. When I square this, I get the first term squared minus 2 times the first times the second plus the second term squared. Okay, so let's write that. So 1 plus cosine twice x over 2 times, the denominator is 4. The numerator, as you already told me, 1 minus 2 cosine twice x plus cosine squared of twice x.
Now we're using the double angle formula?
Not yet. Very good question, actually. If I use the double angle formula, I'll be in trouble because, again, I'm going back to something squared. I don't want any powers other than 1. I can have cosine x, I can have cosine twice x, I can have cosine 3x, I can have cosine 5x, cosine 4x, 9x, but nothing squared. That's why this is called reducing the power. Okay, use the formulas for lowering powers to rewrite the expression in terms of the first power of cosine. Cosine of anything but the first power.
So it's always a half angle formula?
Yes. Yes. So if I go back and rewrite this as cosine squared minus sine squared, or 2 cosine squared minus 1, then I have to change it back into no power. Good. So first of all, I'm going to multiply 2 and 4 and put it in front. 1 over 8. And then I'm going to distribute 1 to these 3, 1 to these 3, and then cosine twice x to these 3. Because it's multiplied. I multiply the tops and I multiply the denominators. Agreed? So 1 distributed to these 3 is 1 minus 2 cosine twice x plus cosine squared twice x, and plus, can anyone dictate? And since I may not have enough room, I'm going to erase this bracket from here and put it in later.
So we got cosine twice x. So plus cosine twice x.
Very good. Plus cosine twice x minus, yes?
2 cosine squared.
Exactly. So I got in trouble again, but I have no choice. So minus 2 cosine squared twice x, and plus, you are going to say correctly cosine cubed of twice x. I'm not going to multiply it though. I'm just going to write cosine twice x multiplied by cosine squared twice x, and then close the bracket. And if I ask you, why did I leave it like that? And why did I say cosine cubed?
Oh, because
I cannot lower the cube. I am restricted to only power 2. Only power 2 can be changed into this. Power 3, I can't. Good. So now let's see what is acceptable. So this is acceptable, this is acceptable, I will combine like terms. This is not acceptable, this is not acceptable, but I will combine like terms. And this is not acceptable because they still have powers on them. Okay, so now I copy 1 over 8 in front, copy the bracket. 1 is alone for now. I see negative 2 cosine twice x and the positive cosine twice x, so this is minus cosine twice x. And I'm done with these 3 terms for now. Now I see a positive cosine squared twice x and then negative 2 cosine squared twice x. So I'm going to change this into negative cosine squared twice x, but I want to use the formula. Cosine squared twice x will be 1 plus cosine 4x divided by 2. So 1 plus cosine 4x divided by 2. And I finally got to this. This is the last term. So plus cosine twice x is okay. It has power 1. I don't care about the argument. But multiplied by, what do I change cosine squared twice x by? What do I replace it by? Exactly. I replace it by 1 plus cosine 4x divided by 2. And I will be done after I simplify this. There are no more other powers for any cosine but 1. So 1 over 8 in front, 1 minus cosine twice x. I will separate this fraction. I'm coming up to this fraction. I will separate it into negative 1 over 2 and negative 1 over 2 cosine 4x. I separate into 1 over 2 plus cosine 4x over 2. Don't try to simplify. That's just the coefficient in front. Then I separate, I'm at the last term now. I separate this into 1 over 2 plus 1 over 2 times cosine 4x, and at the same time I distribute cosine twice x. So 1 over 2 distributed to cosine twice x is positive 1/2 cosine twice x. And then I have 1 over 2 times cosine, so positive 1/2 cosine twice x, cosine 4x. It's not done. But we are getting there. I know. I will have to agree. Okay, now 1 over 8. The 1 minus 1/2, 1 minus 1/2 is 1/2. I heard that. I didn't. I'm just kidding. I didn't. Honestly, I did not. I was just trying to be funny. Okay, so these two are done. Now this with this, -1 plus 1/2 cosine twice x is minus 1/2 cosine twice x. And these are done. There is nothing I can do to this. I just copy a -1/2 cosine 4x. And I copy the last one because I can't do anything to it. Cosine twice x and cosine 4x. The final step is to distribute 1/8. And it's done. So 1/8 times 1/2, 1/16, minus 1/16 cosine twice x, minus 1/16 cosine 4x, plus 1/16 cosine twice x, cosine 4x.
How many of these are we able to?
One.
Oh, yeah. Gonna be like this one?
No. Easier. But you have to remember the two formulas.
So we're. Except one.
Yes.
I'll make sure I count.
Yeah, maybe I messed up something. I would rather go back.
Oh, wait, no, he did.
You would.
So you replace.
I already know that I can't get away with anything in this class. I'm kidding. Of course I don't. I don't want to. If you see something, no, you have to let me know. Yes, Parker, go ahead.
Yeah, I was just thinking, so,
Here.
yeah, right there, when you first simplify to get 1 plus cosine 4x over 2, what did you replace? Oh, okay, so.
So this is 1 plus cosine 4x over 2.
That's the formula.
Because it's the same formula, but now I apply it to 2x. Yes.
That was just my.
Anything else? This was, I have no idea which problem it
It
was.
was number 13.
I don't know how they presented the answer. Do they present it as everything over 16, or they have these 4 terms? They should have these 4 terms and not just write one fraction. It's a 13-page.
They just wrote one fraction, and they just put, and then they put in parentheses the rest of it.
They have one fraction over 16?
They have one, no, they have 1/16 and then in parentheses the rest of it.
Oh, they did not distribute.
Yeah.
Okay. Everything else is okay. Oh. Well, I would not keep parentheses, but that's okay. It's acceptable. Good. Anything else? Yes.
Sum the product.
Yes, those formulas will be given to you if I choose to put something. I will.
Oh, okay.
You will not have to memorize any of
Okay,
those. No.
Okay.
The ones of
They changing from a sum into a product and from a product to a sum. You will see those. They are necessary for Calc 2. But I'm not asking you to memorize those right now. No. Anything else? So let's go to the end of chapter 7 and review. Let me select a couple of problems and let's work on problem 9 on page 530. Sine squared x times cotangent squared x plus cosine squared x times tangent squared x. Please show that this is 1. And when you finish, let's work on 22, same page. Cosine x plus cosine y squared plus sine x minus sine y squared. They say it equals 2 plus 2 cosine x plus y. Just copy the first one, finish it up, and then we'll go to the next. Then I would like to work on 37. Just copy them after we finish the first one. 2 cosine squared x sequentially. I hear some flipping.
We can put those on the test.
I'm trying to retrieve that email. Maybe it's still there.
Yeah.
Okay, can we work on the first one?
Oh, yeah.
Is the first one done?
Oh, yeah.
Everyone? Do I need to show it? Do I need to show the first one? Are you all sure? Andrew, are you okay? Do I need to show the first one? Okay. So are we working on the second one?
Yeah.
Okay.